Okay, so chapter 3, as you guys probably read, is an introduction to chemistry. And before we get into chemical reactions and things like that, we've got to talk about what everything is made of. So we need to talk about atoms first. Okay? All right, so you guys that are in here, go ahead and be listening while you underline and whatnot. So it says, imagine that you're cutting fabric to make a quilt. You cut a piece of fabric in half, then you cut each half in half again. And the question is, could you keep cutting the pieces in half forever? Well, around 400 or so BC, a Greek philosopher named Democritus thought that you would eventually end up with a particle that couldn't be cut. And he called this particle atomos, which is a Greek word that means that you can't cut it, not to be divided. Okay? Aristotle, who is another Greek philosopher, disagreed. He didn't believe that such a particle could make up all substances found in nature. But neither Democritus nor Aristotle did any experiments to test their ideas. And it would be centuries before scientists tested these hypotheses. So, within the past 200 years, scientists have come to agree that matter is made up of small particles, and Democritus's term atom is used to describe those particles. Okay, so the essential question was, okay, so we're unpaused after the interruption. But anyway, did you underline these two sentences? And I put over here, remember that matter is anything that has mass and volume. And all matter is made up of what? Atoms. All right. And number 5 asks, who was Democritus? Well, Democritus obviously was a Greek philosopher, and he was the one that's credited with coming up with the notion that there was a smallest fundamental particle to things, and that once you got there, you couldn't divide that particle into a smaller substance. Okay, so he's credited with coming up with the idea of an atom. Does that make sense? All right. All right, so we're now on page 115. And we're going to start talking about atoms. Remember that the word atom comes from the Greek word atomos, which means uncuttable. So you need to take your pen or highlighter and find that definition for an atom. It's the smallest particle into which an element can be divided and still have the properties of that element. So it's the smallest piece of an element that can still be that element. One atom of gold, for instance, is the smallest piece of gold that still has all of the properties of gold. One atom of carbon is the smallest part of carbon that still retains all of the qualities of carbon. Do you understand that? Okay. Now, when we talk about elements, remember we're talking about pure substances, and where do we find the list of all of the elements that are known? On the periodic table, okay? So if you had a chunk of copper or a chunk of gold or a chunk of whatever, okay, you're talking about some sort of element. And again, elements make up compounds such as salt and rocks and all of this stuff. But if you are talking about the smallest part of that element that still has the qualities of that element, then you're talking about an atom. Is everybody okie dokie with that? Okay. You cannot see individual atoms. They are way, 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 way too small. How small? Well, if you took a penny contains about 2 times 10 to the 22nd atoms. I don't even know how to say that number other than in scientific notation because there's so many zeros after the 2.
It's over a billion.
Okay? It says that's almost 3,000 billion times more atoms than there are people living on Earth, and there's like 7 to 8 billion people on Earth. So, can you see atoms with a microscope? No. The only thing that comes close are these electron microscopes, and then you get some sort of image that's sort of like this. Okay? So if you went over to the cabinet and got out a microscope and looked in the microscope, you might be able to see an enlargement of, for instance, this is a piece of moss. You'd be able to see what moss looks like up close, but still you'd have to enlarge this many, 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 many more times to get down to an atom. Got it? All right, go to page 116. All right, so remember 400 BC or so, Democritus proposes this idea of an atom. He says, there's got to be some sort of fundamental uncuttable piece of everything. But we didn't do a whole lot with that idea, or that idea didn't evolve or start evolving until about a little over 200 years ago. And John Dalton is credited with some pretty major contributions to atomic theory. And number 7 says, as you read, underline the 4 main ideas of Dalton's theory of the atom. Well, John Dalton's theory was based on evidence from experiments, so he didn't just, he wasn't like Democritus. He's like, I believe this happens. He actually did experiments, and the statements that he made were based on the experiments that he did. First of all, he stated that all matter is made up of atoms. That's number 1. Atoms cannot be created, divided, or destroyed. That's number 2. All atoms of a certain element are identical. And atoms join with other atoms to make up pretty much everything we know of. Now, it's important to know that some of the statements that he made we now understand are not true, but it still represents a big, big leap in our understanding about atoms. Okay? Does anybody know which ones are not true?
The atoms join with other atoms?
No, atoms do join with other atoms to make new substances. That one's true.
That all atoms of a certain element are identical.
All atoms of a certain element are identical. That's what Dalton said, but we now know that there are actually some varieties. For instance, carbon. Not all carbon atoms are identical. Okay? There are different varieties of carbon known as isotopes, and they're slightly different. We'll talk about what makes them different later on. Okay? They're still atoms of carbon, but they're not identical. So this one, not true. We have later figured out. Also, can we create, destroy, divide atoms?
No.
Yes, we can.
Yes.
Okay, that's fission and fusion. Okay, but they didn't have any understanding of that stuff, back in 1808 when he was doing all of this. Okay? All matter is made up of atoms. Yes, we still understand that to be the case. So he said several important things, some of which, we've had to revise because of new evidence that came out. But anyway, so John Dalton said several different things, important things about the atom. Almost 90 years go by before we have anything significant as far as new information or discoveries about atoms. And here comes J.J. Thomson, and he does some experiments with a cathode ray tube. And he figures out that atoms have negatively charged particles within them. And those negatively charged particles we later call electrons. Okay? And J.J. Thomson uses the information from his experiment to sort of come up with a different model, which basically looks like this. It was often called the plum pudding model, if anybody's familiar with that. We don't eat plum pudding much in this country, but if you can imagine pudding with little chunks, or think of raisins, a raisin cookie or something, you've got this substance with little pieces in it, okay? And what his little pieces were the electrons, kind of embedded in the rest of the atom. Does that make sense? All right, so he's doing his experiments and coming up with his theories in the late 1800s. Y'all okay with J.J. Thomson? Sure, Miss Goff. We love J.J. Thomson. All right, So fast forward, I don't know, 18 or so years, and along comes our next significant contribution from Ernest Rutherford. He does an experiment called the gold foil experiment, where he's basically shooting, I think it was helium nuclei or whatever, at a really super thin sheet of gold foil, and he notices that most of the time stuff just goes straight through. And part of what he concluded from his experiments is that the atom is actually mostly empty space. We have a dense nucleus. So Rutherford is credited with coming up with the notion that there's a dense nucleus in the middle, surrounded by electrons. Okay? He also later is credited with figuring out that there are protons in the nucleus. Okay? So that is, now we're closing in, that's about a century ago. Got it? All right. Just a few years after Rutherford, Niels Bohr comes along and contributes a little bit more to our understanding of the atom. And he says that, according to his theory, you have, yes, the dense central nucleus, and then you have little orbits, kind of like planets orbiting a sun, okay, that electrons stay in. So he proposes that we have these little orbital levels for the electrons. Okay. We now know that that's not really the case, but we still do use Bohr models quite a bit because it is an easy simplification to show us some of the things about an atom. So he wasn't like completely off. It's just we've tweaked the theory a little bit. Is everybody okay with that? All right, so what is the current atomic theory? Our current understanding is that we don't have orbitals like Bohr said. We have an electron cloud, a big area around the nucleus where electrons are likely to be found. Okay? And depending on the energy level of the electrons, you have sort of energy shells, energy areas. If you notice that this electron cloud, there's like this central blue area, and then there's a lighter blue and a lighter blue. Those would be those energy levels, okay? And one of the things about the current theory, the electron cloud theory, is that you can't really tell exactly where an electron's going to be at a particular time, okay? You can just kind of say it's likely to be here. Does that make sense? Okay. And so we have figured out that, it's likely that in this lowest energy level area, we're likely to have 2 electrons and 8 electrons in the one outside of it, etc. Okay? They also give you a little tidbit about James Chadwick discovering that there were neutrons he did that in 1932. So now we understand, as of 1932, we now understand that the nucleus is made up of what? Protons and neutrons. Who discovered protons? Rutherford. Okay. Chadwick, neutrons. Who discovered electrons? J.J. Thomson. Okay. So now we've got a theory as to how we think the atom works. Okay. We've got protons and neutrons in a dense central nucleus surrounded by a large electron cloud where our electrons are likely to be found. Capiche?